For today's lesson, we will be discussing about the differentiation rules for trigonometric functions. So last time we discussed about the different rules for the exponential and logarithmic functions. So this time we will be focusing with the trigonometric functions. Let's start with the derivative of a sine function. The derivative of the sine function f of x equals sine of x is given by, so d over dx of sine of x is equal to cosine of x. So the derivative of sine of x is equal to cosine of x. So for example, we have f of x equals 4 sine of x. So to get the derivative of this, since 4 is just a constant multiple of the function, so we can just factor it out like that and then multiply to the derivative of our sine of x. So we have now f prime of x is equal to 4, then the derivative of sine x is cosine of x. So this is now the derivative of our function. So again, the derivative of sine x is equal to cosine of x. Next, for the cosine function, so the derivative of the cosine function f of x equals cosine of x is given by, so we have d over dx of cosine of x is equal to negative sine of x. So they're just the opposite of one another, but this time the cosine or the derivative of cosine will be a negative sign. So here, example, f of x is equal to 10 cosine of x. So f prime of x is equal to, then we have 10 times the derivative of our cosine. So the derivative of cosine is negative sine. So times negative sine of x. So therefore, f prime of x here will be equal to negative 10 sine of x. So this is now the derivative of our function. Again, for cosine, its derivative is negative sine of x. And for the derivative of a tangent function, the derivative of the tangent function f of x equals tangent of x is given by, so we have d over dx of tangent of x is equal to secant squared of x. Again, the derivative of the tangent x is equal to secant squared of x. Example, so f of x equals 3 tangent of x. So f prime of x is equal to, so again we have 3, just multiply it like that, and then get the derivative of our tangent of x, which is secant squared of x. So therefore, the derivative now of our function is 3 secant squared of x. So there. So that is now the derivative of our function. Again, for tangent, its derivative is secant squared of x. And then for cotangent function, so the derivative of the cotangent function f of x equals cotangent of x is given by, so we have cotangent of x is equal to negative cosecant squared of x. So as you notice, a while ago for cosine, its derivative is negative. Now for cotangent, its derivative is also negative. So you just have to remember that one. And then we have cosecant squared of x. So it's negative cosecant squared of x. Example, f of x equals negative 6 cotangent of x. So we have now the f prime of x is equal to negative 6 times, and then we get the derivative of cotangent of x. So that is negative 6 times the cotangent of x is, the derivative of the cotangent of x is negative cosecant squared of x. So if we multiply this, negative times negative, therefore the derivative of this is 6 cosecant squared of x. So there. Again, for cotangent, its derivative is negative cosecant squared x. Next, derivative of a secant function. So the derivative of the secant function f of x equals secant of x is given by, so secant of x its derivative is secant of x times tangent of x. So there are now two functions for the derivative. Secant of x and then times tangent of x. Example. So we have here f prime of x is equal to, then we have the 2 times secant of x. We get the derivative of that. So we have 2 times the derivative of secant x is secant of x times the tangent of x. So therefore, the derivative of this function is 2 secant of x times tangent of x. So that is now the derivative. Again, for secant of x, its derivative is secant of x times tangent of x. And lastly, for the cosecant function, its derivative is negative cosecant of x times cotangent of x. So again, as you can see, it's a negative as well. So if the function is cosine, cotangent, cosecant, its derivative is negative. So for cosecant of x, its derivative is negative cosecant of x times cotangent of x. So let's have some example here. F prime of x is equal to 3 times, and then we get the derivative of cosecant of x. So that will be times negative cosecant of x cotangent of x. So you just have to multiply by negative. So we have negative 3 cosecant of x cotangent of x. So this is now the derivative of the given function. Again, the derivative of cosecant of x is negative cosecant of x times cotangent of x. Now let's try some examples, and this time let's try to combine other techniques that we already discussed with the examples for trigonometric functions. So let's try this example. F of x equals the square root of x sine of x plus tangent of x. So what we will do is we just have to apply some of the techniques that we already learned about derivatives. So as you can see, we have here two terms, square root of x sine of x and tangent of x. So for the tangent of x, we don't have any problem. It can be solved as is. But for this one, square root of x sine of x, so we have to apply here the product rule because square root of x is multiplied to sine of x. So we will be using the product rule. So we have u and then v for the sine of x. So let's solve this. F prime of x is equal to, so let's apply the product rule to the first one. So u dv, u dv plus v du, v du. And then for tangent, all we have to do is just to add the derivative of it. So plus d over dx of tangent of x. So let's now solve for the derivative. So we just have square root of x here. For the sine, its derivative is cosine of x plus, and then we have the sine x. For the square root of x, its derivative, we have to apply here the power rule. So square root of x can be written as x raised to 1/2. It can be written into its exponential form. And then we just have to apply the power rule here. So you multiply the exponent here in front. So you have a 1/2 x, and then you subtract 1 from the exponent. So it will be negative 1/2. And then to fix this, to make the exponent of x positive, you just have to put it in the denominator. So therefore, 1 over 2 square root of x is the derivative of square root of x. So let's write here 1 over 2 square root of x plus, and then the derivative of tangent, it is secant squared x. So let's just write here. And then all we have to do is just to arrange everything or simplify. So here square root of x times cosine of x plus, then this one we can multiply the sine x to the numerator, so we have sine of x all over 2 square root of x plus, and then just write secant squared x. So this is now the derivative of the given function. Let's have another example. H of x equals 2 raised to x cosine of x minus sine of x over x. So with this example, as you can see the two terms, we can just simply solve for the derivatives. You have to apply the product rule for the first one and the quotient rule for the second one. So let's do it. So this one is u, this one is v. This is our high, this is our low. So again, we will be applying the product rule and the quotient rule simultaneously. So we have h prime of x is equal to, so let's apply now the product rule. So u dv dv plus v du v du minus, and then we have to apply the quotient rule here. So just separate them with parentheses, and then low d high minus high d low all over low squared. So we have x squared. And then let's simplify this. So we have 2 raised to x as is. Cosine of x, its derivative is negative sine of x. Plus, and then we have cosine of x. Now for 2 raised to x, this one is exponential function, and it's in the form of a raised to x. So its derivative is a raised to x ln of a, which is 2 raised to x ln of 2. Minus, and then for this one, let's just solve this. So we have x, and then the sine of x is cosine of x minus sine of x times 1, which is the derivative of x, all over x squared. Now for this, we just have to simplify. So our final answer here will be, so just multiply the negative. So negative 2 raised to x sine of x. Then for this one, we have plus 2 raised to x ln of 2 times cosine of x. And then for this one, we just have to distribute the negative sign. So this will be minus x cosine of x plus sine of x all over x squared. So this is now the final answer. So this is now the derivative of our function. And for our last example, so we have g of x equals logarithm of x base 2 minus 6 tangent of x plus x squared cosine of x. So there are 3 terms. For the first one, we have to apply the rule for logarithmic function. And then for the second one, we just have to solve for the derivative of this, and then for the third one we have to apply the product rule. So let's do it here. G prime of x is equal to, so we have to get the derivative of logarithm of x base 2 minus, for this one you just have to write 6 and then multiply it by the derivative of the tangent, like what we did in the previous examples. Plus, here we have to apply the product rule. So we have u and v, because again, x squared is multiplied to cosine of x. So u dv plus v du. And then let's simplify. So for this one, the logarithm, so its derivative should be 1 over x ln of a, or since a is 2, it will become 1 over x ln of 2. So that's the derivative of our logarithmic function here. Minus, and then 6 times the tangent x, its derivative is secant squared x. And then we have plus x squared Then cosine of x is negative sine of x, that's the derivative, plus then we have cosine of x, x squared, its derivative is 2x using the power rule. And then let's just simplify this. 1 over x ln of 2 minus 6 secant of squared x. And then here, just put the negative sign here. Negative x squared sine of x plus 2x cosine of x. So this is now the derivative of the given function. So we will just have a continuation of our discussion about the differentiation rules for trigonometric functions. So let's have this example. F of x equals ln of x, secant of x, sine of x. Okay, so as you can see here, we have here three terms and they are being multiplied together. So there are different ways on how we can solve this. So I will be showing you two ways on how we can solve for the derivative of this one. So first is by using the product rule. Remember, in product rule, we use it if the terms are being multiplied together. And the one that we know is that if there are two terms that being multiplied, then we can apply the product rule, which is the udv plus vdu. But since there are three, so we will just tweak the product rule a little bit. So here we have three terms, so u, v, and w. So the idea behind product rule is that we are getting the derivative of each term and then we multiply it with the remaining one and then we just add them. So instead of having the usual udv plus vdu, we will have, since there are three, u dvw. That means we're getting the derivative of v and then we multiply it with u and w. Plus, and then let's get now the derivative of u. So v du w. So in this case, we have the derivative of u, it's being multiplied by v and w. And then last, we have to get the derivative of w. So it's now u dw v. Okay? So again, what we did here is we're getting the derivative of each term and then we multiply it with the remaining terms. And then we just have to add. So let's apply this rule. So f prime of x is equal to u dvw. So u dv w sine x plus v du w. V derivative of u w plus u derivative of w times the v, which is secant of x. Now let's get the derivative of each function or each term. So we have here ln of x only. For the derivative of secant, it is secant of x times tangent of x. And then we will just copy sine x. Then plus, we have here secant x. Derivative of ln of x is 1 over x. And then we have sine x. And then last is we have ln of x. Then the derivative of sine is cosine of x. And then secant of x. So as you can see, the terms here are quite long. So what I will do is I will try to simplify. Now, how are we going to simplify this? Take note that trigonometric functions are involved here. So what we can do is we can rewrite some of the trigonometric functions so that we can further simplify the function itself. So let's try with the first one. So we have ln of x times secant of x times tangent of x times sine of x. So what we can do here is, let's just copy ln of x. And then, secant of x is multiplied to tangent of x. So secant of x can be written as 1 over cosine of x. That's the reciprocal of our secant. And for our tangent, tangent can be written as sine over cosine. So sine of x over cosine of x. And then for sine, we'll just leave it as like that. So sine of x. So let's focus with this one first. So we have, in the denominator, we both have cosine of x. And then for the numerator, we have the sine x. And then we have the ln of x. So what we will do is, we can just multiply all of them. So we did not change the sine x because if we change the sine x, it will just give us another trigonometric function, which is we don't want because we want to simplify. So let's just multiply this. So let's just leave ln of x here, and then let's multiply sine and sine. So that will be sine squared x all over cosine times cosine, that's cosine squared x. So there you go. And then we can simplify this. Sine over cosine is tangent, but since it is squared, so that will be tangent squared x. So there. So that is now the simplified first term. So next, let's proceed with the second one. So we have here plus. Now secant, we can again change this into 1 over cosine. And then for the sine, we will leave it as is again, because if we change sine, or if we rewrite sine into its other form, it will become 1 over cosecant, which will not lead us to anywhere. So just leave it as like that. And then we have the 1 over x. Plus, so let's now multiply sine and 1 over cosine. That will give us sine x over cosine x. And then we have the 1 over x here. Now sine over cosine is the same as the tangent, so we can just write it tangent x and then multiply to 1 over x. So we have tangent of x over x. And then down to the last one. This one is also ln of x. Cosine of x, we can change this to... Now the secant of x, we can again change this into 1 over cosine. And as you can see, after we change it to 1 over cosine, we now have, or we can now cancel the cosine of x. So therefore, we're just left with ln of x. So we have here plus ln of x. So this is now our final answer. So this is one way on how we can solve for the derivative of this function. So let me show you the other way on how to do it. So a while ago, what we did is we used the product rule, and then after we use the product rule, we simplify. This time, what we will do is we will try to simplify it first. So we have f of x equals, so instead of having 3 terms, we can change it actually into 2 terms only. So we have ln of x. Now we have secant, and then we have sine. So we can transform secant of x, or rewrite this into another form, which is 1 over cosine of x. So that is again the reciprocal of the secant. Then we have sine x here. Now from here, you can multiply the sine with 1 over cosine. So we will be having here ln of x sine of x over cosine of x, which is just equal to tangent. So therefore, our new function will be ln of x tangent of x. So from here, we were able to simplify it into 2 terms only. So here, we can now apply again the product rule, but this time it will be simpler. So f prime of x is equal to u dv plus v du. And then let's just solve. So ln of x, the derivative of tangent is secant squared x, plus this one is tangent of x, the derivative of ln of x is 1 over x. So we have here ln of x secant squared of x plus, and then multiply tangent of x over x. And then that's it. This is now the derivative. So as you notice, these two are different. Okay, they are different in form. But if you just simplify the other one, it will be the same as this. And if you substitute a particular value of x, you will still get the same value. So they are just the same. So it's up to you to choose which one do you think is easier. Well, obviously, this step right here is easier to solve. Let's have another one. G of x equals x cosecant of x minus logarithm of x. So here we have two terms. And in the first term, we have to use the product rule. So this is u and this is v. And then we just have to get the derivative of the second term and then subtract it with the first one. So let's have g prime of x is equal to u dv cosecant of x plus v du, which is x, minus, let's get also the derivative of the logarithm. So derivative of logarithm of x. So here we have x. The derivative of cosecant is negative cosecant x cotangent x plus, then we have the cosecant of x, then the derivative of x is 1, minus, for this one, the logarithm of x, we will be using the rule for the logarithms, which is 1 over x ln of a, where a is the base. But since this is this one has the base of 10, so we'll use here 10 as well. And then let's just simplify this. So the negative sign, will just multiply it with the x. So negative x cosecant of x cotangent of x plus, this is cosecant of x minus 1 over x ln of 10. So this is now our final answer. So this is now the derivative of our function. Now, why we did not transform the cosecant or cotangent into other form? So no need to do that, because it will not lead us to simplification of our function, because the reciprocal of cosecant is 1 over sine. The other term for cotangent is cosine over sine. So we cannot cancel anything. So there's no need for us to do that one. So this is our final answer. And for the last one, so let's have this cotangent of x over cube root of x. So here we will be using the quotient rule. So this is high, this is a low. So h prime of x is equal to low cube root of x low d high minus high d low all over low squared. Okay. So let's solve for the derivative, cube root of x. Then we have here cotangent of x, the derivative of that. The derivative of cotangent of x is negative cosecant squared of x. Minus, and then we have the cotangent of x. And then we have the cube root of x. So what's the derivative of the cube root of x? So this can be written into its exponential form, which is x raised to 1/3. Okay, so whatever the index is, that will be the denominator of the power or the exponent. So we have x raised to 1/3. And then from here, we will use the power rule. So it will become 1/3 x raised to, then 1/3 minus 1. So that is negative 2/3. And then, since we don't want a negative exponent, we have to put it into the denominator. So we have 1 over 3 x raised to 2/3. So we can just leave it as like that. So let's write 1 over 3 x raised to 2/3 all over the denominator, which is the square of the cube root of x. Now, since the numerator involves a fraction, so we have to simplify this by getting the reciprocal of the denominator and multiplying it to the numerator. So what we have is, that's right here, cube root of x times the negative cosecant squared of x minus, then let's multiply this two. So you have cotangent of x over 3 times x raised to 2/3 times the reciprocal of the denominator, which is 1 over the cube root of x and then squared. So from here, we'll now have to multiply this to the numerator. So let's multiply. So let's multiply to the first term. So this one. So it will be in the denominator. So we have the cube root of x times negative cosecant squared of x. This is cosecant all over the square of the cube root of x minus, and then here let's multiply this cotangent of x all over. Now we are multiplying 3x raised to 2/3 and the cube root, the square of the cube root of x. Now to do that, what we will do is we have to transform this one into its exponential form so that we can multiply it to the denominator. So the first denominator is 3x raised to 2/3, and then we're going to multiply it with this one. So the cube root of x raised to 2, so cube root of x raised to 2 is just the same as x raised to 1/3 squared, which is, if we simplify, will be x raised to 2/3. So the exponential form of this denominator is equal to x raised to 2/3. So again, we're multiplying the denominator of this and then this one. So in multiplying, so we have here 3x, and then if you multiply variable, you just have to add the exponent. So 2/3 plus 2/3, that will give us 4 over 3. So this is now the denominator. So let's write here 3x raised to 4/3. Okay, so now this is our function. Now go back to the first term here. We can see we have cube root of x on the numerator. We have the square of cube root of x in the denominator. So that means we have 2 cube root of x in the denominator. So what can we do with that? So we have 2. So we can cancel 1 of that cube root. So we will be left with 1 cube root of x in the denominator. So let's write it again. Negative cosecant squared of x all over, then we have the 1 cube root left, minus, and then this one. Okay, now that they have different denominators and 2 different fractions, we just have to write them as 1. So since the second term is in exponential form, we have to make this one, the denominator of the first term, into its exponential form as well, so that we can get the LCD. So let's just write negative cosecant squared of x all over the exponential form of cube root of x is x raised to 1/3 minus cotangent of x all over 3x raised to 4/3. Now we have to get the LCD. So the LCD of these 2 functions or these 2 terms will be 3, then x raised to 4/3. Now why 3? Because the coefficient of this is 1, this is 3. So the LCD of 1 and 3 is 3. And then we have 1/3, we have 4/3. And if we get the LCD, we are considering the variable with the highest exponent. So we have here 4/3 for the LCD. So that's why the LCD of this 2 functions or 2 terms is 3x raised to 4/3. And then all we have to do is just to write them as 1. So we have 3x raised to 4/3. So how do we solve for the new numerator? It's LCD divided by the denominator times the numerator. So let's start. LCD divided by x raised to 1/3. So we have there 3 x raised to 4/3 divided by x raised to 1/3. So we will be left with 3. And then for the exponents, if we divide, what we do is we subtract. So 4/3 minus 1/3, that will give us 3/3, or just equal to 1. And we have the variable here, so that means that will be equal to x only. Okay? Again, LCD divided by the denominator. So we have 3x raised to 4/3 divided by x raised to 1/3. So 3 divided by 1 is 3. 4x raised to 4/3 divided by x raised to 1/3, that will just give us x, since we have to subtract the exponents. So 4/3 minus 1/3, that will give us 3/3. That makes now the exponent of x equal to 1. And then after we divide, we multiply it to the numerator, which is negative cosecant squared of x. So therefore, we have negative 3x times cosecant squared of x. Okay? And then, for the second one, since this is already, or the denominator is already the LCD, so we just have to copy the numerator, which is minus cotangent of x. And then, that's it. That is now the derivative of our function. So that's it for today. I hope you learned something about solving or finding the derivatives of trigonometric functions, and see you next time.